Hello and welcome to our lesson on vectors in space for our trigonometry class. This is going to be from section 9.6 and we have a few formulas to go over. First, we have the formula for the standard form. And this standard form formula is for a three-dimensional vector. Vectors in space means vectors in three dimensions: x-axis, y-axis, z-axis. The next two formulas are for finding the standard form of a vector. The first one is if you're given 2 points, namely the initial point and the terminal point. And the other formula is the M and D formula, which means you would have to be given the magnitude and the direction angles. The next formula is for finding the magnitude of a three-dimensional vector. And last, we have the formula for the dot product. These three formulas over here for alpha, beta, and gamma, those are the direction angle formulas. And what these are going to give us for our three-dimensional vector, they're going to give us the angle the vector goes in the x direction, y direction, and z direction. And now that we've talked about all the formulas, the next thing we need to do is look at some examples. All right, here we go. First example, we're given the initial point P, -2, -1, 4, and terminal point Q, 6, -2, 4. And the instructions say, write V in the form of AI plus BJ plus CK. That means find its position vector. So again, it's important to note that P is the initial point and Q is the terminal point, which means that point P is going to be x1, y1, z1, and Q is going to be x2, y2, and z2. And then we're going to go to our formula and plug and play. Since we're given 2 points, we're going to be using the 2-point formula. So our vector is going to be 6 minus -2 I plus -2 minus -1 j plus 4 minus 4 k. And then we just simplify. 6 plus 2 is 8i. -2 plus 1 is -1j. So you can put -1 or you can just put -j. And here 4 minus 4 is 0k. So you can either write plus 0k, or if you want, you can just leave that off. That would be okay. And there is our position vector in standard form. And that's all we need to find for that example. Next example. Here they give us vector V is 3i minus 6j minus 2k. And it says find the magnitude of the vector. So here we're going to plug into the magnitude formula, which is the square root of a squared plus b squared plus c squared. And then we just need to work that out. 9 plus 36 plus 4. 36 and 4 is 40, plus 9 is 49. And so it looks like the magnitude, which remember also represents the length of the vector, is 7. And that's all they ask us to find for that example. Moving on. In the next example, they give us vector v is 3i minus 5j plus 2k, and vector w is negative 2i plus 3j minus 2k. And here they want us to find 2v plus 3w. So this is going to be some vector algebra in which we are going to substitute. So 2v is going to be 2 times vector v, 3i minus 5j plus 2k, plus 3 times vector w, negative 2i plus 3j minus 2k. And then we're going to do the distributive property twice and CLT, combine like terms. All right, so that's going to give us 6i minus 10j plus 4k minus 6i plus 9j minus 6k. And then CLT, combine like terms. And then CLT, combine like terms. Our i's are going to cancel. I've got negative 10j plus 9j. That's going to be negative 1j, or just negative j, plus 4k minus 6k. That is minus 2k. And that is our answer in standard form. That's all they want for that example. Next example, we are given vector v is 3i minus 6j minus 2k. And here they ask us to find the unit vector. And I didn't actually write that formula down in this section because it's identical to the unit vector formula we have covered previously. So that formula is v over the magnitude of v, which is the original vector, divided by its magnitude. 3 squared plus negative 6 squared plus negative 2 squared. And remember, when you're doing a unit vector, you do need to divide the fraction up into 3 individual fractions so that you can see the coefficients for I, j, and k separately. All right, so here we go. We're going to have 3 over, what is all of that going to work out to be? You know what I'm going to do? I'm going to use the calculator because I'm lazy. I mean efficient. That's going to be 3 squared plus 6 squared plus 2 squared. And if you're wondering why didn't I put the negatives in, it's because those are going to end up being positive anyway. And so that'll give me the correct answer. So that's going to work out to be a whole number, 7. So that's going to give us 3/7 I minus 6/7 j minus 2/7 k. And that will be our unit vector. Next example. Here they're going to give us vector v is 2i plus j minus 3k. And vector w is I plus 2j plus 2k. And in this example, they want us to find the dot product and the angle between the two vectors. So to find the dot product, remember in a previous lesson I said product means stack them. V dot W, we're going to multiply the A's together. 2 times 1 is 2. We're going to multiply the B's together. Again, 2 times 1 is 2. And we're going to multiply the C's together. That's going to give us minus 6. And then we just need to add 4 minus 6, negative 2. And there's our dot product. Now, to find the angle between the two vectors, that is going to be the inverse cosine of the dot product divided by the magnitudes multiplied. So here we are going to have to find the magnitude of V and the magnitude of W and multiply those. And this is going to take a little bit of work. Here we go. Inverse cosine of negative 2 over square root of, and then for the magnitude of V, that's going to be 2 squared plus 1 squared plus negative 3 squared. And for the magnitude of W, 1 squared plus 2 squared plus 2 squared. And next, simplifying, inverse cosine of negative 2 over the square root of 9, 10, 14 times the square root of 4, and 4 is 8, and 1 is 9. And the square root of 9 is 3. But since we're having to work with that anyway, I'm going to leave that square root of 9. And we're going to grab our handy-dandy calculator and do the inverse cosine of negative 2 over square root of 14 times the square root of 9. And if you wanted to put times 3, that would be perfectly fine. Same difference. And since we're in degree mode, we're going to get a degree answer, and we're going to round that to the nearest 10. 100.3 degrees. That is the angle between the two vectors. And I'm going to show you that this can be verified with the calculator. If you watched my previous video, you know that in the menu setting, there is a vector app. And so if we select number 5, we can define vector A. Now this vector A is going to correspond to vector V. It is a 3-dimensional vector, and the coefficients are 2, 1, and negative 3. Now if you hit Option, you can define vector B. It's also going to be 3 dimensions, and vector B is going to correspond to vector W. The coefficients are 1, 2, and 2. And then we're going to hit clear, and we're going to check the dot product. So we're going back to Option. Let's choose vector A, Option, down, dot product, and then Option vector B. And this will do the dot product V dot W. Verifies that our dot product is correct. And then we can also do the angle between those two vectors. And I'm going to go back to the front, hit Option, down arrow, angle. And I need to delete the dot and instead have a comma. That is Shift, close parenthesis. And the angle between the two vectors is 100.3. verified. So the calculator will verify your vector dot product and the angle between the two vectors. Kind of cool, actually, in my opinion. All right, so for our last example, here we're going to be given vector v is 3i minus 6j minus 2k. So in this example, it says find the direction angles of the vector and then write the vector in this form. Using the M and D formula, we're then going to express the vector in this form here. But first, we're going to have to find the direction angles in order to express the vector in this form. So here we go. First, to find alpha, inverse cosine of A, which is 3, divided by the magnitude of the vector, which is going to be 3 squared plus negative 6 squared plus negative 2 squared. And I'm going to slide this over. So if we scroll up a bit, you're going to see that we have already done this calculation for the magnitude of V. It's basically the same vector that we've done before. So I already know what that's going to work out to be. That's going to work out to be 7. And so alpha is going to be the inverse cosine of 3/7. And the inverse cosine of 3/7 is, and I think we're going to round that to the nearest tenth, 64.6 rounded. That is the direction angle for alpha. Next, we're going to need the direction angle for beta. And that's going to be the inverse cosine of, and I don't need to do this calculation again. It's just going to be the inverse cosine of B over the magnitude, which is 7. We've already done that work. And then pulling up the handy dandy calculator, this is going to be super easy. We're just going to backspace, delete the 3, and put negative 6. Rounded, whoa, look at that. 9 to the nearest tenth would be 149.0. 149.0 rounded to the nearest tenth. And then for gamma is going to be the inverse cosine of C, which is negative 2 over the magnitude, which we know is 7. And pulling up the handy dandy calculator, delete and 2 to the nearest tenth, 106.6 degrees. Now that we have the direction angles, alpha, beta, and gamma, we can now plug into the M and D formula and write the vector as the magnitude, which is 7, cosine of alpha, which is 64.6, I, plus cosine of beta, 149.0, J, plus cosine of gamma, 106.6 K. And I'm going to scroll back up just to make sure that I got that correct. Yes, so it's going to be the magnitude times cosine of alpha I plus cosine of beta J plus cosine of gamma K. And that is exactly the way that I have written this answer here for our vector using the direction angles. And at this point, I believe I have covered everything that you're going to need to be successful in section 9.6. So if you have any questions or comments, feel free to leave those in the comment section below, or you can text me. And thanks for watching.